Here we are showcasing smart factory workflow for the side core of a low pressure die casting die for the head of an engine cylinder block for a car. And at this stage, we are scanning the head of the engine cylinder block using Hexagon Absolute Arm, which is a scanner. We collect the 3D point cloud data corresponding to the geometry of the head of the engine cylinder block. And .stl file format is the output. At stage 2, we convert the 3D point cloud data into mesh. Then from mesh, we create a surface, and from surface, we create a solid. So we have the solid geometry corresponding to the head of the engine cylinder block using VG reverse. Then at stage 3, we do the designing of the side core by extracting the surfaces from the head of the engine cylinder block model, and that is done using VisiCAD. At this stage, we do the design validation of the design of the side core using MSC Apex products. So we apply the boundary conditions on the side core, such as temperature, pressure, which are there during the low pressure die casting process, and check for stress and deflection and ensure that they are within the acceptable limits. If there is any deviation, we go back and change the design and redo the design validation process again till it is within acceptable limit. After design validation stage, we can visualize the performance of the product using Cradle SC Flow from MSC Software Solution through virtual reality experience. At this stage, we create the machining toolpath using WorkNC, which is our flagship CAM software. Then we import the entire CAM project into NC Simule, which is our platform for creating digital twin of the machine tool. Using NC Simule, we can optimize the tool path, check for collisions, and make corrections to avoid if any. Here we can see the actual manufacturing process being done on a vertical machining center. We use MNH probe, again from Hexagon, to do the alignment for the workpiece in the beginning. And once the machining is completed, we again use MNH probe from Hexagon to measure on-the-job dimensions. This is how we complete the on-the-job inspection first. At this stage, we are doing the final inspection of the side core using Chroma CMM, where we take all the measurements of various parameters, and those are populated in PCDMIS software, where we get to know whether the measured dimensions are within the acceptable limits or not. Various measurements taken are transferred from PCDMIS to our QDAS platform, through which we monitor the process capability using various statistical quality control techniques. We make it smarter using Hexagon products. So these are smart factory dashboards using which we can monitor and control the smart factory process and also take corrective and preventive actions as and when required based on the current signal received. For example, we have smart factory asset management using which you can understand the performance of various assets. For example, coordinate measuring machine. We can understand also various machines, their current state, and also various parameters related to machine. For example, spindle speed, load, temperature. And if there is any abnormality noticed, we get an alarm signal so that we can take the corrective action. So it also helps for predictive maintenance. We also have integration with enterprise level products such as ERP, and also we have augmented reality using which we can understand the current status of the parameters for a component. And also we are showcasing here regenerative design techniques using which you can optimize the design of a product. So a lot of information available here used to monitor, to control and take corrective and preventive action so that we make the workflow smarter.